Good morning. Thank you very much for joining us today with us to hear about Windows 10 and the platform innovation that we're doing. And I really appreciate that you taking time out on your busy day schedule. And on the keynote, you have seen today that, my colleagues Shen, Dave, and even Elliot talked about the kind of investment that we're making in Windows 10 platform, which we call it an evolution of Windows 10, right? So in this session, I'm going to focus on how do we build apps? What is that which is changing from a developer perspective? What is that we are bringing for developers to realize this opportunity called Windows 10? So before I get into this session, I'd like to ask you one question. How many of you have developed Universal Windows 8.1 apps? Okay, we have few, right? So let's start from there. When it comes to Windows 8.1 and Windows Phone, the way the universal apps, we have introduced the term universal apps when it comes to Windows 8.1 and Windows Phone, where you have a common code base that you're actually sharing across phone and as well as Windows 8.1. And Windows 10 as an evolution has gone far beyond that capability, right? So we bring you one common core, one binary that actually runs across all these Windows 10 devices. What does it mean? It means actually there will be a guaranteed one core API layer across all Windows 10 devices. And on top of that, each device family will have its own unique API layer that would allow you to take advantage and tailor the experience that's required for you to actually, suitable to the kind of user, who is interacting with your app on a particular device, whether it is phone, tablet, PC, IoT, HoloLens, or even Surface Hub. So from a developer perspective, what it means is it's a great opportunity. On top of that, one package that gets into this one single store that can be published across all this variety of devices. So what we're going to talk in this lesson is actually what are the new innovations that's happening in XAML. We have seen some of the controls that my colleague Shen has shared in the morning about how we are actually using the XAML control, right? How do we actually conditionally identify and query an available API on a particular device? So how do you actually take advantage of that? And how you tailor the experience of your app to a specific device that you're targeting, right? And also, what are the new performance enhancements we are making in XAML? What are the tools enhancements we are doing in Visual Studio 2015? And also, the app model philosophy of Windows 10. And at the end, I will also touch upon compiling your apps on .NET Native. So that's the essence of my talk today. So let me get into the most first thing of all. When it comes to actually building apps, since we are talking about variety of devices, running across multiple resolutions, multiple form factors, tailoring the experience actually starts from your UI, right? So that's how you actually bring the XAML. That's how you actually design the XAML. So what we have done is we put a very big thought process. We have done a lot of hard work that's actually bringing the convergence of Windows Phone and Windows 8.1 back into this Windows 10, right? As you have seen, we brought this iconic pivot control, that's into Windows 10, which is familiar for Windows Phone. And when it means, it actually provides you some of the common scenarios. Apart from pivot control, what we have done is that actually the hard work is bringing these common scenarios automatically as part of the platform. You don't have to design specifically for that, right? So the pivot control works, in a tabbed form, or defaults to its default behavior depending upon the kind of input modality that user is using. You might be using a mouse, or you might be swiping with a finger. Apart from that, building app for a universal Windows platform, right? We call it as UWP apps, actually requires you to be more adaptive. The UI and the design needs to be more adaptive because you don't know on which device the app is going to be presented, right? That's how you actually, so we brought a lot of major improvements in XAML controls. One of them is relative panel, which you have seen in the morning. What exactly is a relative panel? It's a kind of style that actually defines the behavior of the UI when it's presented on a device based on the relationship between its children. That means you can completely avoid nested layouts, which makes you more adaptive and tailor your app depending upon the experience that you wanted to show it to your users, right? Apart from relative panel, we also brought something called adaptive triggers. When it means to adaptive triggers, this based on the state trigger, the kind of resolution on which it's running, you can actually define the way you want it, the width or reduce the width or tailor the experience that you wanted to show it for your user. So these are some of the cool new features that we are actually working towards and making improvements in XAML simultaneously while actually providing you a lot of out-of-the-box kind of experience where we are making the platform to do a lot of common scenarios. So you don't have to go and write, so that you can focus on making your UI more intuitive, more responsive, and more adaptive. So let me take a quick look. Let me show you another aspect of the same triggers, right? What you have seen in the morning demo was adaptive triggers. It's all about, it's a default thing that comes for you out of the platform. So there would be some cases where you want to custom that entire experience and you wanted to write your own kind of, responsive triggers based on, your own layout requirements, right? Say if user is using an input, say if he's using a pen on a Surface tablet, or if he's using his finger to swipe, and we provide you some default behaviors. But not only that, you can actually extend the same flexibility of adaptive triggers to your own custom triggers. That we call it as extensible triggers. So let me show you a quick demo on what exactly is extensible triggers. So what we have here is actually a simple class. Let me get into the class and show you. Yeah. So here, if you see, I have written a simple class which actually extends from state trigger base, an abstract class, from which I'm going to tailor the experience I needed based on the user. So I'm extending the capability of an adaptive trigger in the form of an extensible trigger. I'm customizing that experience. So I have defined here a simple platform name, and I qualify my UI based on the device family I'm running on it. And when it comes to XAML, all I have to do is I go here and I define, trigger a behavior depending upon whether my app is running on a desktop or whether my app is running on an Xbox or phone, come what have you. So that also gives you, this also shows the kind of investments we are making in XAML, right? So we give you the basic experience which comes out of the platform for most of your common scenarios, but you might want to tailor the experience, right? So a great app when you start building, right, all about universal UWP apps starts about bringing that adaptivity at every level. Because as I told you, the diversity of devices is plenty. We talked about billions of devices of opportunities, right? So there could be any possibility, every possibility that your app might run on different devices based on DPI density, based on screen resolution, based on the size, and how do you actually tailor that experience based on the real estate that's available to you and for your app. Not only that, what you're seeing here is a great additions to what we are doing from the MVP, from the ecosystem, where you can see lot of customizable extensible triggers, like how you're going to do it, how to do it, how do you customize your experience based on that. So we are also co-developing, and we are actually developing as part of the with the ecosystem itself. So that actually gives us the flexibility to actually understand the investments the community is making, get feedback very early. Now that's very important, right? The whole thing about Windows 10, UWP, and UWP, Universal Windows Platform Core API layer that we are talking, is all about giving you guys an early preview, early peek into the things, and also reading the response back and trying to make changes based on the feedback that we are getting from the ecosystem. So this side actually gives you a lot of inputs, a lot of examples on how to customize your extensible triggers and how to design your own triggers. So there are a lot of other UI goodies are coming. One is, as you have seen in the morning, notification, dependency on properties, and also composable 3D transforms, which allows you to actually provide some beautiful, UI experiences to your users based on, by applying simple effects like 3D rotations or parallax, these kind of experiences. And guess what? You don't have to write any specific code to get this done. Majority of this is actually done with a simple control, right? Just like adding a simple 3D parallax. I'm going to show you in a while about it, and how to apply that effect and how to get that effect onto your apps. Apart from that, Chrome. You can customize Chrome. You can brand it. You can size it. Because all Windows 8 apps are windowed apps, Windows 10 Universal apps are windowed apps, so you can customize the Chrome and you can brand it and size it the way you want it. In one of the demo today morning, you also seen the cool new feature called drag and drop, which is very unique for Universal Windows platform. So I'll show you a quick demo of one of the other UI goodies. So if you're seeing here, as you know, parallax, right? We all know. We're all physics and engineering and mathematics students, so we know what parallax is all about. Let's say about background camera, in Symfony with front side text, right? When user is moving, if parallax is properly handled, it's easy for the user to read and intuitive enough, right? So all I have done in this demo is I have defined a transform 3D for a scroll viewer. When user is scrolling through my text on my app or the content of my app, I have applied a perspective transform. I have applied a perspective transform 3D, and all I want is I'll display an image in the background, and naturally when user is scrolling between the content, I want it to be more intuitive and more engaging experience. Most likely, mostly for apps that has a lot of content and publishing and stuff like that. So what you're seeing here is actually a Mount Rainier picture. So from Seattle, I'm a hiker, so I have this picture. So if you've seen there, but the text below is the parallax effect. So as I'm scrolling slowly, as I move, you could see that it's slowly moving up. So it allows me to actually seamlessly, create a basic parallax effect by just declaring transform 3D on my scroll viewer, right? So these are the other cool UI goodies that's coming up as part of Windows 10 Universal UWP app developments, right? So moving on, it's not just adding controls. It's not just bringing new UI goodies. It's not about giving you an opportunity to build an adaptive design, but it's also improving the performance. When we say UWP apps run across multiple devices, right? Diversity of devices. Some devices might have a low memory footprint, and some devices could be high-performing computers. There could be a Surface Hub, 84-inch, right? So anything. So you have to take these things into consideration and design your app. So what we as Microsoft are doing is, while giving you the flexibility of design, and by providing you more and more optimizable controls and experience, and giving you adaptive way to design, make your app more adaptive and intuitive and responsive, we are also improving XAML performance in Windows 10. So one of the key features is we are actually running the same XAML in our shell and in our apps. This gives us great insights into how XAML is performing and what we can do to improve that performance. So all our Microsoft apps, and we constantly look at this application insights and go deeper into the app and go deeper into the XAML performance and try to bring improvements. So that's one way that we started. That means we are developing with you. It's not just that developers, but it's also we are part of the same thing. And apart from that, we are considering actually giving you a notable improvement in performance. When you take an existing 8.1 app and just upgrade to Windows 10, you will see a CPU cost savings of around 15%. Similarly, there's a working set improvements of another 20%. So that's actually tells you how easy and how intuitive our performance goals are, right? So any Windows 8.1 app, you can easily upgrade to Windows 10 and see the actually great improvements in the performance. And how many of you have actually downloaded Windows 10 Insiders? How many of you are registered? They're good? Okay, good number. Cool. Do you heard about Xbind? How many of you have heard about this word Xbind? One person, my friend. I like it. So we all know why this is important. Because the heavy lifting is done at the compile time, right? By generating a code for all your binding during compile time rather than runtime. That itself brings phenomenal improvements into your app's performance, right? So we bought this cool new Xbind as part of our XAML XAML improvement, as part of XAML performance improvement, apart from actually co-developing the apps along with you and trying to understand how our shell is doing in XAML versus how our apps are doing on XAML, right? And next feature. Suppose if you have apps which are pretty data intensive and there are long lists, right? So loading them at runtime and compile time, and actually, if there is a very lengthy data, it's actually loading that one shot gives you a lot of time. It takes a lot of performance. What we have introduced in Windows 10 UWP apps is Xphase, which allows you to actually load based on where you want, progressively render the data that you want from your XAML controls, from your markup. So by default, it's 0. Anything else comes after that is 1. So this is also, apart from Xbind, Xphase is another control, another XAML improvements that we are bringing to target our performance goals for XAML. And another cool feature, Xdefer. Why do I need this? Basically, I don't want all my visual, all the XAML visual elements to be actually, swamping my UI. I just want some of them to actually load when I want it. So I can defer the initialization at a later state based on user's action or the way you want to define it. So joining with Xbind and Xphase for phase-wise rendering or progressive rendering of your data, and we bring Xdefer, which actually allows you to defer the rendering of some UI, some XAML elements based on when you want it to be rendered, right? So let me quickly show you a demo of Xdefer. Cool. So what I have here is actually, let me run this app before we get into the actions. So I have an app. I have defined some deferrals, some custom deferrals, some basic deferrals, and I wanted to also some control temporal difference and stuff like that. So when I click this element, I want some of more UI elements to be rendered. So I wanted to defer rendering of that UX elements until a user actually presses this button. So let me close this app quickly and then go back to the code. So if you look at my basic deferral, right? I have defined something here called, oops. Yeah, if you see, I have actually defined a button here, and then once the user clicks here, I want it to be rendered, right? Apart from that, when we look at this Visual Studio tool, there are a lot of cool new features here. Let me go back, and then as one of the design improvements also, I can actually go to this app, I can actually go to this drop-down, and look at how my UI looks, when it is rendered on different devices. So what I'm seeing here is actually, on a 6-inch phone, how my UI looks. And if let me go back to my Surface Hub, let's see how it looks. So it actually scales itself automatically. The design element, automatically scales to the way it's going to be rendered when it comes to that particular device, right? So let me get back to the contest. What I have defined here is actually, a lazy deferred strategy. I'll define a grid. I've added 4 elements to that, 4 simple rectangles, and I have added some colors. What I want to do is display this only when user clicks. Is it actually really working? Let's see. So before I actually also get into this, I want to show you another cool feature of the same Visual Studio tool. So here I have a click event, right? So what you usually do to look at the code behind this click? Anybody? I want to go to the definition of this code. Usually what you do as a developer, you click F12, it takes you to the definition, right? But I don't need to do that. I can just be here and press Alt F12 and look at the code here. That's peek into the definition itself. So as I told you, my deferred grid, actually all I want to do is, I have added a event handler here for click, which tells me that, okay, the moment user clicks this, all you have to do is find out where is the deferred grid and then load it, right? So that's what I wanted to do, right? You realize this grid when users presses the button. That's also, from a design perspective, you have the ability to see where your UI is, how your UI looks when I'm running on a 6-inch tablet or I'm running on an 84-inch Surface Hub, right? So you can look at here itself. You don't have to, go and then and apart from that, another cool, why I'm actually linking these two is basically XAML performance, improvement in the Visual Studio tools go hand in hand. They have to go like romancing each other and understand how it's working for improvement. So now, let me go and click this button. Cool. My app's running. Now here in the Visual Studio, I have already in the visuals tree, live visual tree, I want to see whether is there a deferred grid already loaded or not. So I'll just go and check. So there's nothing, right? So I don't have anything which is deferred grid or anything, it's not loaded. It just has 4 elements and it's not loaded. So let me go here and then click. So now I have these 4 elements loaded. So let me go to my live visual tree and actually look at, look at the elements that's been loaded. So now if you go down the grid, say here is my rectangle that I have loaded, right? So I can right click, look at the properties, and I can, now if you look at this app, there is something wrong in this logo, right? Do you know? There's something wrong in this logo. The color is not looking good there, right? So while my app is running, let me go to my Visual Studio and then just modify the color. Let me see if it actually reflects back here. That's it. So while I'm working, actually while my app is running in the background, I'll go to my live visual tree selector, and I went here, I looked at the live visual tree, and I've changed the color on the spot. It's not just color, it could be any input that you wanted to change live on the fly while your app is running, right? That's another cool feature about Visual Studio. And also, what you're seeing here is diagnostics tool. Understand the memory usage, understand CPU usage, how the CPU is performing, how the memory is performing, and as the debugger is running, put breakpoints where you want, and then understand the performance peaks and these things, right? So improving XAML adding new controls to XAML, making XAML more and more intuitive and responsive and adaptive. We're also adding a lot of improvements in the performance of the XAML. Parallelly, we are bringing the same power to the Visual Studio for you to actually use those tools and design your app on Windows 10 UWP apps. Right? So, let me go back to my slides. Cool. Now, how do we actually start making improvements to your app, right? When it comes to performance improvement of your apps, it starts from profiling your application, right? Profile your application and see if there is really a problem in the code, right? I always used to say, even my demos, we are the people behind the build demos, right? So we always say, hey, my code is working on my machine. It's cool, Or maybe most of the developers think that, their code works very well on their machine. I don't know what's the problem. That's a common problem across the world, I believe. So, and at the same time, so first thing is to actually take a look at your code. How you can optimize and improve the code. And second thing is actually, using Visual Studio to use the performance tools and to analyze and understand and then fix the issues, right? So when it comes to improvement of performance, while we are actually doing this, we're also giving you the power and flexibility of using the tools to improve your application and improve your UWP apps and improve the performance. As we have seen, like this is basically, I showed you the demo. I'm actually establishing the fact that this is how we are parallelly improving Visual Studio Tools too, right? So the new XAML language service built on Roslyn, completely decoupled from the code. You can actually see the UI, how the UI tailors depending on the different devices in the designer itself. And peak. While you're actually writing the code, you actually go to the peak. Most cases where designers and developers work together is building these apps. On UWP apps, when designer is writing something and the developer has written a code, the designer has an opportunity by sitting in the same code and then peek into that particular event code and then take a look at it. And the next is the visual tree inspector, which you have seen. While I am tailoring, like all about UWP apps is actually ability to tailor the experience based on the device on which the UWP app is running. As we told that, it's, as we are talking, there's too much of diversity and it could be anything from 6-inch to 84-inch, HoloLens, headless, like IoT devices. So that's the great opportunity we have. What we're talking here is UWP apps is actually building about this diversity of devices, one binary, one package, on a guaranteed core API surface layer, at the same time, unique device-specific APIs that's very unique, very specific to a particular device. So apart from that, the profiling tools allow you to improve, optimize, get insights into your app, enhance them, and use those intelligent tools to understand where your code is breaking, where actually you have an opportunity to improve the CPU levels or opportunity to improvement performance, right? So that's actually what we are providing as part of Visual Studio improvements. Now let me go next. How many of you are designers in this audience? Pure designers. Cool, we only have developers, but still, some of you could be, some of you, I'm a developer, so it's the same community. It's like the same community feeling, right? So we're all same. And there could be many designers like my colleague in the morning, Dave. Dave is a designer, so there could be somebody who's purely design, right? So Blend is also constantly, we are improving that. It's a tool we are creating from the ground up, and which allows you to design a great intuitive and adaptive UI, while Visual Studio is basically a great tool which is well performance to you for a complete integrated development environment, right? So that's what is Visual Studio 2015. And we're also bringing simultaneous improvements into the Blend to support our ambition and our aim of UWP apps, and then enable developers to write those apps more adaptively and more immense and intuitively, right? And next, there could be cases where you don't know what particular API is running on a specific device. There could be cases where you should be able to query programmatically or conditionally understand what API is running. There could be a possibility that, okay, some of the API on the Windows Core API, on the device-specific API, may not be available to you in the documentation. Let's assume that you couldn't find any documentation about that. How do you handle such situations? Right? So these are the cases where you wanted to be able to deploy your app. But before deploying your app, you actually conditionally query the available API in that particular device, and then give that experience that is required for the users. So to achieve this, there are actually two steps. One is, in the Visual Studio, right-click on the Visual Studio and go to the project and references. In the extensions, you add reference to that particular extension SDK of a specific device. So in this case, I'm actually referring to a mobile extension SDK, or it could be an extension SDK for IoT devices, right? First step is basically to add the reference. And second step, query conditionally that particular, go to windows.foundation.metadata.api information, check for is type present. It's a simple string, and just go and check for is type present. If that type is present, what I'm asking here is, in my IoT, hey, does this IoT has a GPIO controller? Then go to that GPIO controller and get the default settings, and then open it and do my programming. Now this app will run on every Windows 10 UWP app. As a UWP app runs on any Windows 10 device. But it will only provide this unique experience when it is actually running on IoT devices. If that unique API is not available on other devices, it just smoothly passes off. If it is there, then it gives that experience, right? So that's what is actually understanding device family triggers. Basically helps you to write an app programmatically also, right? There are two aspects to adaptive design. One is UX, that you design an adaptive UI, adjust the layout based on the screen resolution, or effective pixels, or DPI density, or based on the size of the device that users are doing. And then add state triggers depending upon the default state triggers available to you. If that is not sufficient, then go and customize the triggers by way of extensible triggers, and then design your UI. And as you are building that adaptive UI and building that adaptive code, as you move forward programmatically, you have an opportunity to go and query a specific API of a device, if it is available on a device, using windows.foundation.metadata.api information class. And then if that type is present, ask the app to give the user that great experience. So this, let's talk about app model. We talked about why UWP apps, right? We call it as UWP apps, right? How different it is from the universal apps, which is familiar to you based on Windows 8.1 or Windows Phone 8.1, right? Apart from that, now we talked about the UWP, Universal Windows Platform Core API, which is guaranteed across all Windows 10 devices. We also talked about adaptive design, allowing you to customize your experience tailor the experience based on the device on which the app is running. And other aspects of it is, we also talked about performance improvements. We talked about how are we actually improving the tools, what are the profiling, and what is the opportunity, what are the tools and methodologies you have to improve the performance of your apps, right? Now the philosophy of Windows app model defines the end-to-end app lifecycle, because it runs from any IoT device to that of smallest of footprint of devices to that of larger surface hubs or even HoloLens. So that itself, the app model is actually, the entire app, the platform defines the app model, right? It allows you to scale from all this diversity of devices. You don't have to customize anything specifically for a particular device. All you have to tailor All you have to do is tailor the experience based on the device on which your app is running, right? And complete app lifecycle is managed from install to runtime environment, and then the resource management and update, and data model. We also seen the kind of changes we are bringing in XAML for data binding and stuff, and then uninstall the app. The end-to-end app lifecycle is managed with the platform. That's how the Windows app model works. So that's the philosophy behind Windows app model. Now, when it comes to running your code, universal Windows apps will continue to run on Windows and Windows Mobile. And the classic Windows apps will continue to run on Windows, and the Windows Phone 7, 8, and 8.1 apps will be supported on Windows Mobile. And when it comes to existing Windows Store apps, that is your WinRT apps, they will be supported on Windows, and it will continue to be supported on Windows. So this is the kind of, you may have questions about, I have some existing apps. I have already built some apps on phone. I have already apps on Windows 8.1. And do I support? So this slide clarifies, if you have any doubts about there. Yes, we continue to support that. We continue to do that, and we constantly innovate in that area and helping developers to be more productive, effective in their designs. Now, apart from that, the app model also does multitasking. The resource management scales from very low-end, footprint phones to that of high-performing computers or high-end PCs. And there could be cases where you may have to, extend an execution of a foreground application. Classic example is probably if you are building any document or content, or document signing, or maybe something like an app which requires you to constantly, while user has done some action, it may have to be, before you click close down, minimize the app, and you wanted it to be doing some service and then move the, save the file onto a drive or maybe onto your own personal cloud and stuff like that. That's where you have an ability to programmatically extend the foreground execution of Win10 UWP apps, right? And what it means is you can identify the task completion scenarios of your app and define, say, hey, let me finish this task. Let me complete loading this file or maybe saving this document somewhere, right? And then, it's kind of a turn-by-turn navigation that you wanted to do it. We allow that, right? And apart from that, if you're trying to suspend an app, you have an opportunity to ask for more time before you actually close your app and say, hey, I'm doing something, so let me finish this work before I actually close down the app, right? So the amount of the time that you can query, or that you can actually limit, based on the device, on which device you're running on. So what you're seeing here is actually, it's Windows 10 is kind of an evolution, right? As we've been watching since morning. And to understand that evolution, to be part of this great evolution, and to write your apps, this is the most fundamental basic steps to understand how do you actually, write your apps. How can you extend customize the extension of foreground running your apps and background and stuff like that, right? And apart from that, you also have an opportunity to tell the OS that when you start and how long you intend to, keep running the app. This allows you to actually customize, extended execution of a lot of apps which is running in the foreground. I mean, most of this is coming, all the features that you have seen today, in our talks today, is actually a part of that is feedback that we have received, from a lot of developers, the community, ISVs, enterprise, and line of business application developers. So that's why, and it's constantly listening, we are constantly listening. Now, the navigation model in Windows 10 UWP apps is familiar to Windows Phone apps, which you have seen, Windows Phone 8.1 apps, right? So back button is go back from where you came. So you have an ability to go back inside the app and then go back until your app ends there, right? So this is currently evaluated on Xbox and Windows and some phone models. And The back will behave like a back button in any of the phone that you have today, right? And it navigates within the back, and it goes back to the previous app at the same time, but only start is special. It cannot appear multiple times. But whereas back is like, this is also one of the feedback that we have received, like we want this experience, right? So that's what is, navigation model changes in Windows 10 UWP apps. Oops. Okay. Now, building UWP apps or Windows 10 UWP apps is not just building one app. You are building a web of apps, right? You're allowing apps to integrate using the best of the best web technologies. You can provide URL-based activation and communication to your apps. And apart from that, your apps can communicate foreground to foreground. One of the drag and drop features that you have seen in today's demo is that. It allows you to do that. And it is very similar to the web model. Or if you're familiar with any single page applications, it's pretty much the same, right? It allows for custom scheme navigation kind of scenarios. It also supports that. And what's new in Windows 10 is ability to return results based on, and then query for apps, and enumerate apps based on those things, right? And also we support foreground to background communication, application services, which allows you to, your app would be running in the foreground, but there could be a service running in the background, which is one of the big feedback that we received is on that. Hey, I have an app running in the foreground, but mostly catering to enterprise and line of business apps, right? That's where actually the field I come from. So I constantly observe them. What it allows you to actually, okay, I'm running some background service, so I want my app to be able to communicate and continuously running in the background service, right? And apart from that, and it allows you to publish a background task based on your app need, and that can be called by other apps too. So if you're an enterprise developer, if you're an ISV developers, and you have a set of line of business apps, but you have one app or one or more of those apps or need to be talking to a background service, right? You can do that. You can do that in Windows 10. And at the same time, integration with the social media integrations and people apps and those kinds of things for adding a little bit of fun and social activity around your apps. So what I'm going to show you today is a quick demo on app-to-app communication. So let me close this app. Give me a second. And open up another app here. So, can everybody see the screen? I hope so, from background. So what we have is, if you see, we have two projects here. One is a service, a simple service, which I wanted to run. My app is dependent on. And a demo task. Basically, we have a small demo task. All it does is, I wanted to return a response called ping. Okay? So let's see what it is. And what I've done is, I've created a simple app service name, and I'm connected a new app service connection, and I call the app service name, and I have given that as Microsoft DS App Services Demo, and then package family name. When I actually make this as my default app and run this, you would notice that PFN, package family name. So that's I have registered with my app. Now let me go here and close this, and close this too. So now my client app, which I have written here, all it does is using that service. So the client app has a little bit of event, an action where I want the service, the background service, to respond to my client app based on this action. Now, if I go here, let me run this app, and then see what happens. It says ping. Ping, pong, ping, pong. Okay. So the Pong is coming from a background service. So let's just test whether it is. Now, once I have run my background service, it continues to it support this client app whenever I'm actually running it. Instead of that, let me go and change. So if I make any changes to my background service, I have to restart the service. It's basically once the service is running in the background, the client understand once you have the PFN, the package family name, my Windows 10 client understand that PFN and marries. Okay, I have to listen to this service running in the background. So whenever I have this response, it goes to the background and gets the response, right? That's another great innovation that we bought in Windows 10 UWP apps. So another aspect, like the new adaptive tile template, right, allows you to content that adapts with the tile, the kind of content. It allows you to put the content, how much ever you want, wherever you want, based on the need in a simple XML. And it supports various size formats when it comes to UWP, Win10, UWP apps. So for those existing developers or businesses, ISVs and enterprises who has invested a lot in this Windows 8.1 app, you might have your own legacy templates or toast templates, or you might have designed, but we'll continue to support them. If you feel that they're great, that you wanted to use, you'll continue to use it. What we bought in Windows 10 is adaptive and interactive toast template, one of the most flexible template, right? So the toast template actually it allows you to bring interactivity to your toast. So all the toast, and you can add actions, and you can add responses. You can also design in such a way that you can reply to the user, and based on the notification. And all these toast notifications goes to Action Center, and you have an option to per app notifications. You can dismiss them, or you can actually dismiss individual notification based on the user has that flexibility to do it the way he wants to do it. Apart from that, this could be any beautiful, very productive kind of notifications, like it could be a meeting request, or it could be an alarm that you just want to snooze and dismiss based on the need. So, .NET Native, why does it really matter? The reality is, UWP Windows 10 apps runs on diversity of devices. That's what I've been talking since beginning. The reason is it's very important. There is a possibility that it can run on any low memory footprint to that of any big device. So compiling on .NET Native actually brings you that unique advantage of, native code compilation allows you a lot of performance improvements, enhancements to the performance, right? So it provides a converged developer experience for .NET across devices, running Windows 10 apps, right? And it uses lean kind of runtime and VC++ optimization techniques for fast code execution and reduced memory usage. So if you do a cold start, right? When we say .NET Native, no JIT, J-I-T, right? Just in time. No JIT means less CPU. Less CPU usage means less battery usage, right? By just compiling on a cold startup, you would see actually CPU savings from up to 60%. On a warm startup, it's up to 40%. But on low memory footprint devices, which is actually all the small memory footprint devices, by code optimization, by removing unused types and methods, these kinds of stuff, it provides you 30% optimization techniques, right? So that's why today's world, mobile, the mobile apps or Windows 10 apps requires faster startup. So depending upon the kind of app, kind of device on which the app's running, compiling in .NET Native actually allows you to utilize those benefits pretty quickly. So let me quickly show you. Show you a demo. So to compile my app in .NET Native, all I have to do is to go to the build. So you just checkbox here and then click .NET. So automatically the app compiles on .NET native, right? So, to summarize my talk today, right, what we have discussed is there's a unique opportunity, UWP apps brings you a lot of opportunity for developers, right? So this opportunity ranges from, the changes that we are making to help you realize this opportunity is through a constant feedback. We have received phenomenal feedback, anything from XAML to Visual Studio to requirements on universal apps, UWP apps, and what could be the best make sense with a lot of insiders who signed in with us early, who got into early insight. Apart from that, we got feedback on every aspect of Windows 10 UWP apps. So we are listening. If you have any feedback or anything that you think is important, please let us know. And when you are writing your apps on UWP apps or anything you started writing, signing up for Insider Preview, which we have shown in the morning, you can send the feedback directly from there, and we constantly understand, right? And XAML does the entire hard work for you. We make sure that we bring the converged experience of phone and Windows 8.1 to bring the best of both through pivot controls and through some of the improvements in notification and stuff like that. And we are providing you some of the common scenarios from the platform automatically, right? And allow you to actually customize and tailor based on your users, on which devices your apps are running. So apart from listening and apart from improving the experience that you asked for, we are using the same XAML in the shell and as in our apps. So we are developing along with you. That allows us to understand and monitor the performance and improve the apps, improve the XAML. And the Visual Studio features that you have seen, both from the perspective of the design view and ability to actually peek through the code while you're in the designer, and using the performance and debugger tools to actually optimize and enhance the experience of your apps to your user. And all those things is actually coming up as part of Visual Studio to make your apps more responsive and highly performing applications with given set of diversity that we talked, right? Anything from low footprint to IoT to Surface Hub to HoloLens. And one core API and one binary that's running across all this and one store to publish these apps. So the unified app model across all Windows devices, and a lot of improvements in app-to-app communication, extended foreground execution, foreground app-to-app communication, right? Foreground to background communication, which allows you to build a lot of unique different types of apps based on your needs, based on thing. And apart from that, native code compilation. Compiling your apps, Windows UWP apps in .NET native, improves your performance of your apps by 60% on a cold startup, and 40% on a warm startup, and 30% when it comes to low memory footprint devices. By simply optimizing the code of those low memory footprint devices, where you go and remove all unused types, methods, and functions and stuff like that, and give you a clean binary which can run on these apps. So I conclude my talk today. Thank you very much.